Okay, so we're going to go ahead and do an example of the substitution method. So I've got our 7 steps that we're going to do over here. The last one is an optional step to check our work. We're going to start off with isolating a variable, and then we will use that variable we isolate, and we'll do our first substitution, which is why this method gets the name substitution method. So this first step, isolating a variable, we're going to find any variable out of these 2 equations that we think looks easy to isolate. So you get complete choice, right? There's really 4 different variables you could isolate. You could isolate the x or the y in this equation, or you could isolate the x or the y in this equation. And it's totally up to you which one ever looks easiest. My hint is I always try to pick on the variable that looks the loneliest, which is kind of like a mean way of saying it. You're going to pick on the variable that looks lonely, but it's always the easiest to isolate a variable if it doesn't have any coefficient, any number in front of it. And then usually it can just be isolated in one step. So when I look at this equation, both of these variables have a coefficient in front. So there's a 5 attached to the x and a -3 with the y. So those are both going to take at least 2 steps, and sometimes you're going to get fractions and stuff as you try to isolate those. But this equation, I have a y that has no coefficient at all. The x technically has a coefficient of -1, so it'll be just a little bit easier, or a little bit harder to isolate that compared to the y. So we're going to go ahead and get that y by itself first. That'll be our first isolate step. So to get a variable alone, we're just going to use inverse operations to remove anything on the same side as that variable. So in this case, since I have a -x, I can get rid of that or move it to the other side by using the inverse operation, just plus x. So I'm going to add x to both sides of this equation, which will cancel out. -x and +x would cancel out, and I'd be left with just y equals 2 plus x. Right, that's our first step. We have a variable isolated. Now that I have a variable by itself, I'm able to go on to my next step, and I'm going to use this to substitute into the other equation, to our first equation, or to our second equation. So the key here is, the tricky part is, you got to make sure we substitute the correct variable. So since I know what y equals, I'm going to substitute for y in this equation. So y is equal to 2 plus x. So where I have y in this equation, I'm going to replace it with 2 plus x, since y and 2 plus x are the same thing. So I'm going to take 2 plus x, and I'm going to bring it over to this equation, and I'm going to make my first substitution. I'm going to replace the y in this equation with 2 plus x. So I'm going to rewrite this equation now. 5x minus 3, and then inside of parentheses now, I'm going to replace what y is equal to, 2 plus x, where the y was. So y was here, now I'm going to replace inside of parentheses 2 plus x equals 20. So everything else about this equation is exactly the same as it was before. All I've done is replaced y with what I know y is the same as, what y is equal to. That's my substitution step, my second step. Okay, now we're going to move on to the next step, which is solve. So this is probably the most algebra work, but it's the part that we're a little bit more familiar with, that we've done before. So whenever I'm solving an equation like this, there's going to be multiple steps involved. We're going to try to simplify it first. So the 2 things that we use to simplify equations like this are going to be the distributive property and combining like terms. So the first thing I'm going to do here, since I see a set of parentheses with a number in front, is I'm going to distribute to start to simplify this. So I'm going to take that -3 times both things inside. It's important that I notice this is a -3, and so I'm going to be multiplying 2 and x by -3. So I would bring down my 5x, because that didn't get changed, and now I'm going to do -3 times 2, which would be -6, and then -3 times x, which would be -3x. And that's all still equal to 20. So there I distributed, and now I'm going to go ahead and collect my like terms. I have a 5x right here, and a -3x. And those are both x terms, so I can combine them. Remember, I can't combine -6 with 20 yet, even though they're both constants, because they're on opposite sides of the equation. We're only simplifying one side of the equation right now. So I have 5x plus -3x, or 5x minus 3x would be 2x. And then I'm going to bring down my -6, or my -6, equals 20. Okay, so now we simplified that equation. It's starting to get a little bit easier to solve it. I'm just going to isolate my x now. It's just a two-step equation from this point to solve. So I'm going to get x alone. I need to do the inverse operations of -6 and times 2, which first would be to add 6 to both sides. So I have 2x equals 26. And then my last step, to cancel out a times 2 to get x totally by itself, I would divide by 2 on both sides. So I have x equals 13. So we're now on our steps over here. We've isolated a variable. We used it to substitute, so I only had x's, and I was able to solve for x, my first variable. Now I'm going to substitute again. So you notice we're substituting twice. We substituted the first equation once we had a variable isolated. We substituted it in, and now we're going to kind of complete a circle here. We're going to take what we now know about x, the fact that x equals 13, and we're going to use it back over in this equation, which tells us what y is. Now that we know what x is, and we know that y is just 2 plus x, all we have to do is plug in what we know about x into here, and we can find what y is. So this is kind of completing our circle now, right? We're going to take that x equals 13, and we're going to plug it in for x over here. So this is my second substitution. So now I'm at y equals 2 plus 13, right? I replaced x with what x is equal to, which is 13. And now I'm on to my fifth step, which is simplify this to find our second variable. So in this case, this is really easy math. 2 plus 13 is 15. So y equals 15. Right? So that is really all the work. Our last thing is just to write our solution as a coordinate. So I have my x value, which is 13, my y value, which is 15. So my solution as a coordinate would be 13, 15. And that's my final answer. Right? We do have an optional step here to check our work if we would like to. So I'll show that really quickly. And I have to kind of do it small. But my answer is x is 13, y is 15. So I'm going to go back up to my original equations up here. And I'm just going to rewrite those down here in this space. And I'm going to check to make sure this actually works. So our original equation was 5x minus 3y equals 20. So I'm going to rewrite that equation. But instead of x and y, I'm going to plug in 13 and 15. So we have 5 times 13 minus 3 times 15 equals 20. And then we're going to check to make sure that this one works, and we're going to do the same thing with the other equation because it's got to work for both equations. So the other equation is negative x plus y equals 2. So negative 13, since x is 13, plus 15 equals 2. That one's a little bit easier to check. We can do that really quick. Negative 13 plus 15 is 2. So 2 does equal 2, so it checks out. This one requires a little bit more mental math. 5 times 13 would be 65. Minus 3 times 15 would be 45. And 65 minus 45 is 20. So 20 does equal 20, so that checks as well. So this is the whole process. We isolated a variable, we substitute that into our first equation, which we then went through that whole process of solving, which is where most of the algebra skills actually come into play. We substituted again back into the original equation, and we found our second variable. We made sure we wrote it as a solution, as a point, x comma y, and then if we want to make sure our work is correct, we can plug our x comma y back into both equations, both original equations, and verify that it works. Hopefully that helps with the substitution method.